Hi everyone, today we're going to be presenting on 5G, MVDDS, and NGSO FSS systems. Our team is me, Simrun, Patrick, and Adi. So first we're going to be looking at the frequency schematic. As you can see here, shown in red is MVDDS, which is the incumbent player, and it operates in the 10.7 to 12.7 gigahertz band. 5G is an entrant player that operates in 3 different bands shown in blue on this graph. And NGSO FSS systems, more commonly known as mega constellations, of which the biggest ones are Starlink, OneWeb, and Project Kuiper, operate in the operate in the KU and K bands shown in green on this graph. So first we're going to take a look at the 3 different players and a brief introduction on them. 5G is the 5th generation of cellular technology, and it's faster and offers lower latency. It's in 3 separate bands, as mentioned before, and the lower bands offer greater coverage, so it's useful in sectors like agriculture, and the higher bands offer greater speed. Moving on. So this is more about the implementation of 5G. The FCC is prioritizing it, or incentivizing it being implemented in rural areas, setting aside $9 billion for this, and it's projected to add $1.3 trillion to the global economy, but it's important to keep in mind that this number is just a projection. Some more information is that the FCC is also responsible for auctioning out the bands, and although 5G has come a long way, there are still certain infrastructure challenges that are being faced in its deployment.
Next, we'll talk about one of our incumbents, MVDDS, which stands for Multichannel Video Distribution and Data Service. This is basically a large spectrum for satellite communications and television. It has very fast downloads and low upload times, which is why it's primarily used in TVs. It has actually 2 frequency ranges depending on where you are in the world. In the US, it's between 12.2 to 12.5 gigahertz, and internationally, generally, it's between 10.7 to 12.7 gigahertz. Some of the main providers of MVDDS include RS Access, MDSA, which is basically MVDS for America, and also we have a bit of SpaceX's Starlink accusing MVDS of stifling the ability to use the 12 gigahertz band, which we will talk about more in a second. We also have NGSO FSS, which stands for Non-Geostationary Orbit Fixed Satellite Systems. This is a long word, so we will shorten this to 8 constellations for the purpose of this slide, and more slides to come. This is basically a new paradigm where you have different satellites working together to provide the basic internet services. It spans across a wide orbit with a bunch of satellites working together. Some notable systems include Starlink, OneWeb, and Project Kuiper. And recently, because of, I guess, low cost of materials, it's been brought to fruition in a large scale. I will talk about some more of these NGSO FSS systems. So we have OneWeb, which is found in the KU band. Currently, they're an American-based company which was built out by British and Indian telecom companies. They have they plan to launch about 600 satellites, and their goal is to basically provide basic IoT at lower frequency. They have about 400 satellites currently launched right now, so they're on a good track. Next, we have Starlink, which is a subsidiary of SpaceX. They have a goal of increasing access to relatively inexpensive internet services, and they have about 3,400 satellites launched. And finally, we have Project Kuiper, which is a subsidiary of Amazon, which have about the same goal. They plan to launch about 3,300 satellites, and their first launch will actually be next year in the first quarter.
So now that we know who we're dealing with, let's talk about how this kind of unfolded. Back in 2002, the FCC released rules for the 12.2 to 12.7 gigahertz spectrum, and a couple years later, the FCC awarded MVDDS rights to that band because they won an auction. And everything was fine for a little while. Fast forwarding 12-ish years to 2016, OneWeb comes in and applies for a license into that same band. And Dish petitions the FCC to say, hey, like we can't have these other players in the band, it's gonna affect our ability to serve our customers. But the FCC said, no, we think it's okay for these NGSO FSS systems to actually play in this space. So they say it's okay. And then over the past few years, they've been awarding more and more companies the ability to operate in these bands. More recently, Dish bought into the band, and with RS access, they're petitioning to the FCC saying, hey, these constellation systems will affect our customer base and will also decrease the effectiveness of 5G. Most recently, Starlink was accusing MVDDS of trying to forcefully take over this band, which is supposed to be shared, because they're saying that the way that they're operating is not good for other players. So we're calling this a non-comprehensive interference diagram because we talked about 3 massive players and there's so many moving parts. So this is a simplified diagram just showing kind of the complexity of the space. You got 5G towers, you got MVDDS towers, you have base stations for these satellite systems, and all of the satellites that you have to deal with. So if we were to look closer at one issue, we could talk about 5G and Starlink. We have some array of Starlink satellites trying to communicate with a gateway on the ground, but because of side lobes and other issues, you can actually accidentally create interference for these higher frequency 5G towers. If we were to calculate any or all of these things, these are some simplifications we would make. So we're assuming a roughly constant amplitude of the interference wave. And then we're assuming the angle of incidence to be fixed, even though that's kind of changing over time. We're also saying that it's okay to assume that the system is isolated from other noise, because once you start considering all the other pieces, the problem starts to expand non-linearly. And then the distances can be estimated because they're all in LEO. So how do we mitigate this? There's a couple of things we could do, and it has to do with the angle at which satellites start to send data to a base station. So first, you could specify a minimum angle required to establish links with ground stations. And secondarily, you could specify an angle between satellites. So this kind of ensures some leeway or space between satellites sending information.
So how do we achieve coexistence between our players? We thought of some probable solutions. But first, we have service rule sharing, which involves basically tight coordination and working with each other to decrease power levels where bands cause interference. To achieve this, we also have geographic sharing, which involves a lot of hardware and software intensive work, where they target specific geographical cells. So there will be as little interference as possible. And finally, we have a guard brand, which basically creates this sort of gap between bands, so there's close to no chance of interference. But the issue with this is the players will assume that they have a whole band to work with, but with this solution, this won't be the case.
Yeah, so what can we do? Well, at the end of the day, the FCC gets to make this call. And in worst case, they could implement some sort of band splitting or guard bands, but that would kind of ruin the business model that a lot of these companies have made because they're assuming that they can use this entire spectrum. Another option would be having more auctions for priority. So before there were auctions for who gets to use the band, but there could be some level of arbitration where people don't get to talk over each other, and the FCC can kind of facilitate those conversations happening. That's what we have. Thank you.